Okay, steps. All right, today's changing that we're dealing with radical equations. You've dealt with radical equations before, but first time in this class as a review, so you've seen this before. Of course, they're harder now because this is advanced math. Isolate the radical is the first step. Step 2. Undo. Oh, before I go further, what does isolate mean? Get it by itself. Okay, undo the radical. How would you undo a square root? You square both sides? How do you undo a cube root? Cube both sides? How would you undo a fourth root? Raise both sides to the fourth power. All right, step 3, this is like the meat of the problem. You're going to solve meat and potatoes. All right, and step 4, the step we all love to skip. Check, you are correct. Now,
so there's only 3 steps.
No, and there's a reason why I would put this. Okay, now, I've been saying it on other problems. If there's time at the end of the test, you should go back and check your work. Make sure you verify that your answers are correct, because sometimes it takes too long. On these particular radical problems, you have to check. Everybody hear that? On these particular problems, you have to check. Why? Because you end up with extraneous solutions quite often. What are extraneous solutions again? You do everything right, but your answers just don't work. It happens. Okay, and it happens a lot with these radical problems. So these are ones that you have to check. Now, I'm not going to be like the checker police, checking your homework, checking your quizzes. How am I going to know come test day whether you're checking or not? Right or wrong answer. If you did all your work and you didn't check it and you give them to me and one of them was extraneous, wrong. And I'm going to know you weren't checking. And that's when the points really matter on the test. All right, questions before I get to work?
So maybe extraneous questions.
Yeah, yes.
How do you spell extraneous?
E-X-T-R-A-N, extraneous, E-O-U-S.
Extraneous.
Okay, square root of 4x squared. Okay, it looks like this. And then equals 5. I forgot to go over this with my last period, so I'm going to do it here. We've talked about this before. Can you square Can you square root individual pieces?
No.
Like that's 2x plus 3. No, because there's a what sign in there? Plus. If that was multiplication, could you?
Oh, yeah.
Yes. Oh, yes, you can. All right. Step 1, isolate the radical. Is the radical already isolated?
Yes.
Step 2 is to undo. What do we raise both sides to? Second power. Now, we don't put plus or minus. You put plus or minus when you square root both sides. I have kids ask that sometimes. They undo each other. They're inverses of each other. 4x squared plus 9 equals 25. And what kind of problem is this? Get equal to 0 to factor and solve?
No.
Okay. Now, before we do that, yes, you could. On this particular problem, yes, you could get equal to 0 to factor and solve. But what's missing here? The x, right? If it was like ax squared plus bx plus c, the bx is missing. Do you see that? Yes. Good. Okay. So, could you get this equal to 0, use difference of two squares and factor?
Yes.
Yes. Now, what happens if you get equal to 0 and difference of two squares, like you get x squared minus 5, and it doesn't work? What can you do instead? Get the x squared by itself. All right, so I'm going to do that. But yes, feel free to get equal to 0, difference of two squares. I'm going to get it by itself. Only because I want to make sure you know that's always an option when your bx is missing. 4x squared equals, what's 25 take away 9?
16.
16, thank you. And then we divide both sides by 4. And we end up with X squared equals 4. Done? Square root 2 or plus or minus 2? Darren, did you factor? Did you get plus or minus 2 as well? Yes. All right. Now the only, yes.
You finish, I'll ask it.
Okay. The only reason I did this is because what if you ended up with something like this? X squared equals 5. Would that be one where you'd want to get equal to 0 to factor and solve? No, it doesn't factor. So you'd want to leave it like this and do what to both sides? Square root. All right? Yes. What were you going to ask me?
What parameters constitute an isolated radical? It's like I'm not really sure about
Isolate the radical means there could be stuff inside the radical, but there should be nothing outside. No coefficients here, no plus or minus on the outside. All right? All right. Okay, now what, if I move on, what did I forget to do? Check. Now, I'm not going to be looking for all the check work. I'll know if you check, if you give me the right answer or not. So, there's some that are easy to plug in. You don't have to show me the check work. So would you want to do this one with check work or just plugging in our head? You want to just plug in your head? Okay, I'm going to plug in positive 2. What's positive 2 squared? 4 times 4? 16 plus 9? Square root of 25? Did it work? Okay. Negative 2. When I plug in negative 2, it's negative 2 in parentheses squared. Is negative 2 in parentheses squared still positive 4? And 4 times 4 is 16? Plus 9 is still 25? Square root is still 5? Do both answers work?
Yes.
All right. Questions before I move on? All right. Number 2. And there will be some of you that forget to check on the test. Unfortunately, it happens every year. You just don't check. You don't care if you lose those points. All right. So, step 1, isolate the radical. And I explained what that meant a second ago. There's no coefficients and no plus or minus outside. Is this radical isolated? Yes. Step 2, undo the radical. What do I raise both sides to? Squared. And what does that give us? That undoes each other. Those undo each other. 3x plus 7 equals 2x squared or 4x squared? Okay, is this like the last one where I can get x squared by itself in square root? No, because there's the bx right there. So is this one where I'm going to get equal to 0 to factor and solve? Yes, because we want to use the zero product property. I'm not showing the steps, but when I subtract the 3x over here, what do I get? Minus 3x minus 7. All right, I'm going to let you guys finish from there. And yes, one of your answers is a fraction.
Mrs. Torres?
Yes.
So, when you get the 2x squared over there, are you just distributing the squared to the 2 and the x?
Yes.
You get 4x squared?
Yes.
Okay.
And why can I distribute the exponent? Because this is multiplication.
Yeah.
If that was 2 plus x, I could not.
Yeah.
All right. Or think of it as 2x times 2x is 4x squared.
Yes.
Okay.
Also, is there really a method you use to tell whether or not you'd use, for instance, a 2x and a 2x and a 4x and a regular 1x?
In something like this, not necessarily. If that number had been a perfect squared, I would use 2 and 2 and 6 and 6, or 7 and 7. Something like this, I kind of just wing it and hope. Yeah, I wouldn't do something like this though, because I could see right away that's going to be way too big. So that I wouldn't try. But I can, if I can think of 7 here and 1 there, that might be a possibility. Because 7 and 4 would get the 3. So, yeah. All right, anybody have it? 2 and 2 or 1 and 4?
4 and 1.
4 and 1. 4x and 1x. 7 with the 4, not with the 4. Yeah, because I just said over here would it make sense, right? 7 here. 1 here. Which one's negative? And plus here. Does that give us negative 3 in the middle? Negative 7, positive 4, negative 3. All right. At the 7, divide the 4. What do you get? X equals 7/4. X equals. All right. Now, this one is a little harder to show doing in our head, plugging in 7/4. So I'm going to show the work over here for the plug-in. So there are some times, unfortunately, you just have to suck it up and do the check work by hand. Did everybody hear that?
Yes.
Good. Again, there are some times where you have to suck it up and do the check work by hand. Which one do you want to plug in first? 7/4. 7/4. 7/4. Why would people not want to check the 7/4? It's a fraction. Fractions aren't ugly. It's an ugly number is what was said, and it doesn't reduce, unfortunately. So I'm going to work it out. We're going to try to get through this. What's 3 over 1 times 7/4?
21/4.
Now, I will want a common denominator. So I'm going to make this 4. What do I multiply top and bottom by? 4, and what does that give me? Okay, so I had a young lady ask, why 4? Because I'm trying to get a common denominator. Okay, equals, this is over 1. 2 times 7 is 14 over 4. And I should have reduced first. Are you guys okay if I erase and reduce first? What cross reduces? And what does that become? 7/2. All right. Now over here, I can still add, what's 21 plus 28? 49 over, and what's the square root of 49/4? Did it work? Yes.
Are you going to give us fractions that are extraneous?
Am I going to give you what?
Extraneous fractions.
Oh, possibly.
Because I mean, step 4 is check. I don't feel like checking that.
That's why I just said you suck it up. I don't feel like checking it. Oh, well.
Did you always?
No, I didn't like checking, but I had to.
Okay, well, like with the fractions, did you ever check?
Yeah, yes, I did.
So I'll take it as a no, man. Got it.
Never mind.
It's like, whatever.
All right, which one are we plugging in now? -1. All right, what's 2 times -1? What's 3 times -1? And -3 plus 7. The square root of 4 equal -2? No. Okay, I'm glad you asked that. I had a young man in my morning class ask that. They were like, wait, it could be negative because it's plus or minus. And they said this here, the square root of 4 is plus or minus 2. Is that what you're saying? Okay. You only put plus or minus when you're solving an equation that requires you to square root both sides.
That makes sense.
Okay, so when you square root both sides to solve, you put plus or minus in the front, like this one right here. There was no square root there. We square rooted both sides, we put plus or minus. If there's already a square root in the problem and it equaled something, or we're plugging stuff in, you don't put plus or minus. So does the square root of 4 equal -2? No, it does not. Not in this case. Okay, so our only solution is what? 7/4. All right. Are we good? Number 3. 3 times the 4th root, x plus 3 equals 9. I'm going to let you try that one on your own. That one's doable. Oh, this I haven't really quick. I haven't gone over and isolate like this. So what do I have to do to isolate this? Distribute the 3, subtract the 3, or divide the 3? Gone. All right, now I want you to finish. Can you guys tell me what you did here? Did you multiply both sides by 4 or raise to the 4th power? Raise both sides to the 4. Is there a difference?
Yes.
Yes. 3 times 4 is not the same as 3 raised to the 4th. Okay, undo each other. Please stop the side conversations. 3 to the 4th?
It's 81.
81, and the last step is to subtract 3, and it is?
78.
All right.
I'll write the problem one.
Now, this is one that's easy to just check in our head. Are you guys okay if that's what we do?
Yes.
What's 78 plus 3? Oh,
81.
pause. I forgot to mention this earlier. When you plug these in, you always plug it into the original equation. Before you did any moving, before you isolated, before you squared both sides, original as it was printed on your worksheet or quiz or test. All right, so 78 plus 3?
81.
The 4th root of 81,
3.
and 3 times this outside 3?
9.
Does it work?
Yeah.
Yeah? All right, questions? Yes.
No, I had it, then I was like, yeah, it's cool.
No question after all?
It was like weird because, like, I get it now, but for some reason I thought, how come there's only one solution?
Okay, and it just happened on this one.
Yeah.
Yeah, sometimes there's more than one, sometimes there's one. It really just depends. And sometimes there's none because it's extraneous. Okay. Alrighty.
What do you mean
Now-
sometimes, dude?
Just math.
But you can just make a copy of the key, but that doesn't work, dude. It's still one key, man.
Okay. Writing this one down with me.
Oh, is this the long one?
This is the long one, and this is the baby of the long one. Thank you.
Wait, so it's like
One problem shouldn't have babies.
Megan? Huh? Ooh, is that the right one? Okay, we're going to have to speed up if we want to see our test. So, anybody tell me how this is similar to the other problems on the other pages? Still radicals? Yes.
Can you just square everything?
Okay, I'm glad you asked. All right. They're still radicals. Before I answer that question, how is it different?
it's a plus sign.
There's two radicals. There's a plus sign between the two radicals. And you guys are doing an awesome job at asking awesome questions because these are common mistake kids make on the test, and sometimes I forget to go over them. The question he asked is, can you just square everything? Like square, 25,
Life isn't that easy.
cross out, x plus 5 plus x. Is that what we're hoping for? We cannot do it because of the plus is correct.
Would you square them individually?
What do you mean by square them
Like,
individually?
square x
Parentheses
plus
on
5,
the
and then
each
square
radical.
x, and then square 5? So you get rid of the radicals?
Oh, this was x.
Yeah.
So you're saying like square,
Yeah.
That's the same thing as doing a massive and distributing.
Okay.
Doing it square is saying the same thing as doing a massive squared and distributing. Can we distribute when there's a plus sign inside? No. Yes.
Could you go with an x with a square root in parentheses and a 5 underneath the square root sign with parentheses and then square those?
Oh my God.
It's like super.
Okay, before you give me yours, say yours again. Let me write it down first.
Okay, so you take the x with the x plus 5 underneath the square root sign and have your own square root over the x, and then do the same to the 5, and then do the same to
Like that?
yeah. Would you do that or no?
No. We can't break things apart again. The same reason the plus sign. If that was multiplication, 5 root x, you can do root 5 separate from root x times, but not addition. Yes.
Is that the same concept as putting them all under one square root?
What he asked?
Yeah. Is it like the same, like you can't do it?
You can't, yeah, same thing because of the plus sign. If this had been a multiplication sign, then we could have put them all under the square root and done what he said, one big square root and cancel them all out. If it was multiplication. Yes.
Can you take the square root away and just make it to one of the two?
It would, if you did, it'd be the same rules that we have already.
Do you have to make the 5 square root of 25?
No, good thing. We don't have to use the square root of 25. Yes.
Like subtract one of the square roots of the other.
Good job, Darren. All right. All right.
That's
We're good. I'm going to repeat what he said. Well, actually, Darren, you repeated a little bit louder.
I was just saying, like, you subtract one of the variables to the other side and then just square both.
And then square. That is correct.
That makes sense.
All right. Now, before we do that,
Wait.
that step one was isolate. Now, what problem do we have? There's two. How do I isolate if there's two? So you pick one. It doesn't matter which one you pick. It's easiest if you pick the bigger one to isolate. So Darren said, can we subtract the root x to the other side? Yes. And so I'm going to show you why he said to do this. What happens here? This is gone, right? He said, can we do this so now that we could square both sides, and this side's a little easier. This side is going to be a little more work. Okay, before I continue, do you see that we cannot isolate them both because there's two of them with the plus sign? So you pick one, we picked this one, we move the other radical over. We're going to do what Darren suggested and square. Now here is where it can get tricky. Right here is easy. What ends up happening? It's just x plus 5. Here is where kids tend to make mistakes. We just did a whole bunch of talking about this. Can I square each one individually?
Because there's a minus.
There's a minus. Same reason we couldn't before, we still cannot. The best I can do is do what? FOIL is correct, or double distribution. Now this is where my last class just like, oh my goodness. You guys have the skills to FOIL. It's not much harder foiling with the radical. Yes?
I think you just do that with both radicals on the same side.
Yes.
It would be difficult, though.
It would. Yes, yes, you definitely can. He said, could we leave it like this, square both sides, write it twice, and FOIL? He said it would be more difficult, but can you do it? Sure. A lot more difficult.
Yeah, I think because of the middle too.
Yeah. All right, but doable. All right, so here I'm going to FOIL with you guys. What's 5 times 5? 25. And then 5 times negative root x is negative 5 root x. And then inside is negative root x times 5, which is another negative 5 root x. And then this one is really nice. What's negative root x times negative root x?
X
Just x. Plus or minus if there's two negatives? Plus. So that's what we liked. Doing all of this, we liked it because at least we got rid of that radical. Root x times root x is x. Positive because there's two negatives. All right, I'm going to combine like terms. And there are like terms. 25. Now these here are like, and you add the coefficients. What's negative 5 plus negative 5? Negative, I almost put negative 25. I apologize.
I was scared.
All right. Okay, so we've gone this far. We're not done. Before I go any further, any questions on any one of these steps? None? Okay. Now, unfortunately, we still have a radical. Do you see that? We did all this work, and gosh darn it, there's still a radical, which means we're back to step 1.
We can isolate it.
Okay, now we can isolate it, though. So what are you going to do with the x? Subtract it over, and it does cancel out. And what are we going to do with the 25? Minus it over. It's gone. It's gone. This is, what's 5 take away 25? Negative 20 equals negative 10 root x. And what do I divide both sides by? Negative 10, gone. And root x equals positive what? 2. And what do we do to both sides? Square. Okay, do you agree this part up here was the hard part? Once we got down to here, it was pretty easy. Yeah. All right, what does x equal? 4. I'm going to have you guys do a quick check in your head. Plug it into the original before you did anything else and see if it works. Yes? Okay. Yay. We're good. This was the baby one, yeah. All right. Okay, next one. Square root of 2 minus the square root of 2x minus 3. And then minus another square root. Inside is x plus 2. And then equals 1. Okay. Now, we said it doesn't matter which one you isolate. Isolate the larger one, but if they're both the same size, really just pick one. I'm going to pick to move this one over. Can anybody tell me why this one would be easier? because you just add it over and it becomes positive. For me, I'm trying to keep it as easy as possible, but that does not have to be the one that you pick to move. Okay, square root of 2x minus 3 equals 1, and they're not like terms, so it's plus. Kids will often just say, oh, square root of x plus 2. It's not 1 times that, it's 1 plus square root of x plus 2. The 1 is still there. All right, I'm going to leave you just about in this next step. What do we do to both sides?
We should neutralize it with the radical.
Square, yep. Does the radical and the square here undo each other?
Yes.
That's why we do this step, is to get rid of it on this side. Unfortunately, here we have to FOIL, but we'd get rid of it eventually. And this is where I'm going to leave you. So go ahead and do your double bubble, your double distribution, or your FOIL method, whatever way you think of it, and continue.
I'm going to get another radical.
Yes, and then you go back to step 1 again.
No, but then have to do that.
No, it shouldn't happen after that. It should not happen.
I lost count of how many times we like.
You should only do it the first time, second time.
That's 2 times x minus 2.
Oh, but
So
then
right
it's-
here is a 3
What?
You have to do
What?
all over.
All right, guys, some of you have gotten a lot further, like a lot quicker than I expected. So I do want to address a piece. All right. Okay, this is just 2x minus 3. Do you agree?
Yes.
Oh, wait.
All right. 1 times 1 is 1, plus 1 times that is root x plus 2.
Yes.
And this one is also plus root x plus 2. And at the end, a positive times a positive is positive. And what happens with the radicals? They disappear. They undo each other. X plus 2. All right. Are there like terms on this side? 2x minus 3 equals 3 plus x plus root x plus 2. Okay, now are we back to step 1 again?
Or you forgot to.
We're at right here. Thank you very much. Okay, I was going a little too fast. 1 plus 2 is 3. X stays x, and this is 1. And there's a 1 here as coefficients, and 1 plus 1 is 2. All right. Subtract what to both sides? The 3. And subtract the x. Gone and gone. And what does this give me here? X minus equals 2. Now, how many of you got stuck here with that coefficient of 2? All right. Now, with my other class, I did say it earlier, but I didn't in this class. This guy right here, technically, we should try to divide to get rid of it to isolate. If you left it there, is it okay? It is, because it's being multiplied, not added. Do you see that? So, I would leave it. Some kids divide it and then put it back over. Totally up to you. But do you agree? It would be easier if it was something like that and I could divide and reduce.
Yeah.
But since it's not, I don't want to divide and have a fraction, so I'm going to leave this guy right here. Why can I do that? Because it is multiplication. So now when I square both sides, it's safe because it's not more than one term. So, I've got to write my squared here. This is x minus 6 times x minus 6. Here I do have to square the 2 because it's not under the square root. Do you see that? So here I am distributing because it's one term. What's 2 squared?
4.
parentheses, what happens with the square root and the squared?
It just cancels.
Good, they undo each other. And I'm going to leave you here. What are you going to do on this side? FOIL. And what are you going to do on this side? Distribute. And then get equal to, and after that it's pretty easy. Get equal to 0, factor, and solve. And I'm glad that question comes up because it happens on the test, the dividing part, where it doesn't divide nicely, so what do? Anybody get answers?
Yeah.
Did anybody check their answers?
I have one.
Okay, and did that one of them work?
No.
It did not? Which one did you check that did not work?
2. I got the final was 1 minus 2 equals 1, so it would be a -1.
Okay. Can anybody tell me what you guys got as answers?
2 and 14.
X equals 2 and 14, and you said the 2 did not work?
Yeah.
All right. Are you guys good on working on your own from here? Do this next step if needed. X squared minus 12x plus 36 equals 4x plus 8. Subtract x squared minus 16x minus the 8 is plus 28. Double bubble. All right, did the 14 work?
Yes.
Okay. All right, any questions? Are we good?
Can you just leave that up for a little bit?
Yes. Really quick, I forgot to announce on the homework, we are changing them. Both of them, what worksheets are tonight?
2,
4 and 5. On both of them, we're doing, let me check. Okay. I'm going to put it up here. On worksheet 4, we're doing odds plus 2 and 10. Can you mark that? On worksheet 4, we're doing odds, but also doing 2 and 10. Do you guys recognize numbers 1 and 2 as those type of problems we talked about?
Yes.
And then these down here is the other substitution problems that we talked about? All right. Did everybody mark this one down? And then the next worksheet is just odds. Odd and 2 and 10 for worksheet 4, and then for worksheet 5, just odd.